Hello. Hello and welcome to this read through of PostgreSQL documentation. In this video, we will complete sequence manipulation functions and conditional expressions. So we start with the sequence manipulation functions. I will show examples of these once we are done with this. So this section describes functions for operating on sequence objects, also called sequence generators or just sequences. Sequence objects are special single-row tables created with create sequence. Sequence objects are commonly used to generate unique identifier for rows of a table. The sequence functions listed in 9.55 provide simple multi-user safe methods for obtaining successive sequence values from sequence objects. So usually you don't create these. Let me show you. These are not created manually, but they automatically come in existence. Okay. So you remember our test database and the table which we have created from previous video. So we have customers table. And if you remember, there is Alice, Bob, and Charlie. So three customers are there and their IDs were 1, 2, 3. So if we look at DS, that is list of sequences, then this is customers table and customer ID sequence is generated for us. Its type is sequence. The reason why this sequence is generated because our customer ID was a serial. Similarly, order item ID was the serial. Order ID and product ID were also sequence. Serial. The data type was serial for all these four columns of the row, four different tables. So if you select from, say, customers underscore customer underscore ID underscore sequence, we missed the from. So see, it will say that last value was 3 and the next value will become 4 if we insert more. So the sequence contains the value of the serial column type. So let's study further. Okay. So next val, which class is there, returns a big int. Advances the sequence object to its next value and returns that value. This is done atomically, even if multiple sessions execute next val concurrently, each will safely receive a distinct sequence value. If the sequence object has been created with default parameters, successive next val calls will return successive values beginning with 1. Other behaviors can be obtained by using appropriate parameters in the create sequence command. The function requires users or update privilege on the sequence. So generally, as I said, you don't make these manually, they are automatically created for you. So there's no point stressing over the usage of each of the functions. Just be aware of these. So setval is a rich class, boolean, begin, boolean. Boolean is optional, returns a begin. Sets the sequence object's current value and optional is called flag. The two parameters form sets the sequence's last value field to the specified value and set its is called field to true, meaning that the next val will advance the sequence before returning a value. The value will be reported by per val is also set to the specified value. In the three parameter form, is called can be set to the either true or false. True has the same effect as the two for parameter form. If it is set to false, the next val will return exactly the specified value and sequence advancement commences with the following next val. Furthermore, the value reported by cur val is not changed in this case. So you can set val mySequence to 42, which will give you 43, and set val mySQL 42 to true, which will be same as earlier. And mySequence, you set val mySequence to 42, and you pass false, then next val will return 42. The result returned by set val is just the value of its second argument. This function requires update privilege on the sequence. Then we have curval, returns the value most recently obtained by next val for this sequence in the current session. An error is reported if next val has never been called for this sequence in this session. Because this is returning a session local value, it gives a predictable answer whether or not other sessions are executed next val since the current session date. This function requires users or select privilege on the sequence. Then we have last val, returns a begin. Returns the value most recently returned by next val in the current session. This function is identical to current val, except that instead of taking the sequence name as an argument, which refers to whichever sequence next val was most recently applied to in the current session. It is an error to call last val if next val has not yet been called in the current session. This function requires usage of select privilege on the last used sequence. Now we have a caution. To avoid blocking concurrent transactions that obtain numbers from the same sequence, the value obtained by next val is not reclaimed for reuse if the calling transaction later aborts. This means that transaction aborts or database crashes can result in gaps in the sequence of assigned values. That can happen without a transaction abort too. For example, an insert with an on-conflict clause will compute the to be inserted tuple, including doing any required nextdoor calls. Before detecting any conflict, that will cause it to follow the on-conflict rule instead. Thus, PostgreSQL sequence objects cannot be used to obtain gapless sequences. Likewise, sequence state changes made by setval are immediately visible to other transactions and are not undone if the calling transaction rolls back. If the database cluster crashes before committing a transaction containing a nextval or setval call, the sequence state change might not have made its way to persistent storage, so that it is uncertain whether the sequence will have its original or updated state after the cluster restarts. This is harmless for users of the sequence within the database, since other effects of uncommitted transaction will not be visible either. However, if you wish to use the sequence value for persistence outside the database purposes, make sure that the next val call has been committed before doing so. The sequence to be operated on by a sequence function is specified by a reg class argument, which is simply the OID of the sequence in the PD class system catalog. We do not have to look up the OID by hand, however, since the reg class data types input converter will do the work for you. And we can see section 8.19 for that detail. Now we have some important section coming up, which is conditional expressions. Pay attention here because these are very important. All right. This section describes the SQL compliant conditional expressions available in PostgreSQL. If you need to go beyond the capability of these conditional expressions, you might want to consider writing a server-side function in a more expressive programming language. Although coalesce greatest and least are syntactically similar to functions, they are not ordinary functions and thus cannot be used with explicit quadratic array arguments. So first one is case. The SQL case expression is a generic conditional expression similar to if-else statements in another programming language. So the general idea is you have case, when condition, then result, then when condition, then result, else result. And finally you have and. Case clauses can be used wherever an expression is valid. Each condition is an expression that returns a Boolean result. If the condition of the result is true, the value of the case expression is the result that follows the condition, and the remainder of the case expression is not processed. If the condition's result is not true, any subsequent when clauses are examined in the same manner. If no when condition yields true, the value of the case expression is the result of the else clause. If the else clause is omitted and no condition is true, the result is null. So suppose we have a table select star from test, we have column A 1, 2, 3. Then we can do select A, comma, case when A is equal to 1, then in single quotes 1, when A is equal to 2, in single quotes 2, else other. And then you end and from test. So you get 1, 2, another. The data type of all result expression must be convertible to a single output type. See section 10.5 for more details. There is a simple form of case expression that is a variant of the general form above. Case expression, when value then result, when value then result, else result, and end. The first expression is computed, then compared to each of the value expression in the when clauses until one is found that is equal to it. If no match is found, the result or the else clause of the else clause or a null value is returned. This is similar to the switch statement in C. The example of can be written using simple case syntax. Select a case A when one, when two, then two, else other, and from test. A case expression does not evaluate any sub-expressions that are not needed to determine the result. For example, this is a possible way of avoiding a division by zero failure. Select where case when x is not equal to 0, then y upon x greater than 1.5, else false, and as described in section 4.2.14, there are various situations in which sub-expressions of an expression are evaluated at different times, so that the principle of case evaluates only necessary sub-expressions is not ironclad. For example, a constant 1 upon 0 sub-expression will usually result in division by 0 failure at planning time, even if it is within a case arm that would never be entered at runtime. Then we have coalesce. The coalesce function returns the first of its arguments that is not null. Null is returned only if all arguments are null. It is often used to substitute a default value for null values when data is retrieved for display. For example, select coalesce description short description none. This returns description if it is not null, otherwise short description if it is not null, otherwise none. The arguments must all be convertible to a common data type, which will be the result type of the result. Like a case expression, coalesce only evaluates the arguments that are needed to determine the result, that is, arguments to the right of the first null argument are not evaluated. This SQL standard function provides capabilities similar to NVL and if null, which are used in some other database systems. Then we have null if, and we have value 1 and value 2 in parentheses. The null if function returns a null value if value 1 equals value 2. Otherwise, it returns value 1. This can be used to perform the inverse operation of coalesce example given above. So you can say that select null if value comma none. In this example, if value is none, null is returned. Otherwise, the value of value is returned. The two arguments must be of comparable types. To be specific, they are compared exactly as if you have written value 1 is equal to value 2. So there must be a suitable is equal to operator available. The result has the same type as the first argument, but there is a subtlety. What is actually returned is the first argument of the implied is equal to operator, and in some cases that will have been promoted to match the second argument's type. For example, null is 1, 2.2 is numeric because there is no integer is equal to numeric operator. Only numeric is equal to numeric. Then we have greatest and least. So greatest value and then more values and same for least. The greatest and least function select the largest or smallest value from a list of any number of expressions. The expression must all be convertible to a common data type, which will be the type of the result. Null values in the argument list are ignored. The result will be null only if all the expression evaluates to null. This is a deviation from the SQL standard. According to the standard, the return value of null is null if any argument is null. Some other databases behave this way. And with this, we have come to the end of conditional expressions. And next topic is array functions and operators, which we will look at in the next section. I hope that you have understood all these conditional expressions with clarity, because when we will be doing the practical side of it, they are quite useful in doing stuff. Okay. So if you have got any questions, you can come to my website undika.ashtabak.org and you can make a login here and ask questions to me. You can make use of the tag SQL or PostgreSQL, and I'll be more than happy to answer your questions. So with this, I will end this video here, and we will meet again tomorrow with array functions and operators, where we'll discuss this in the next video. So with this, I will take my leave and I'll see you tomorrow. Till then, have a great day ahead. Happy learning and stay curious. And most importantly, enjoy.